But at Evonik, of course, we also have that. We do sort them into 4 main areas. We have smart operations, which is kind of speaking for itself, digital business, so the interface to our customers. We have human work. We already heard a few things from Oksana there. And we have cognitive solutions. Cognitive solutions refers to where we make use of data, for example, to do analysis, to do predictions. So it has AI, machine learning, digital annealing, quantum computing. But honestly, it also just has a simple regression analysis if that does the job, right? It's not about the technology, it's about getting something solved. Now, I'm personally working mostly in cognitive solutions, so in that part of the company. And we also there have a strategic framework, I would call it, where all the divisions, all the businesses, but also most of the functions are part of. It's called the Cognitive Solutions Agenda. And it does not just focus on implementing use cases, right? Everybody's like, okay, let's implement AI use cases. But it's actually much more about preparing the ground. So we're talking about processes, we're talking about organization, we're talking about really just taking the whole company. So that means, that's the right one, yes, thanks. I recognize my name. So that also includes, of course, hardware, software, but it specifically also includes demystification, communication, technology acceptance, all those things, really to kind of just have the groundwork in place so everybody can come on board. I will not talk about that today. Instead, I will actually just take one small part out of that cognitive solutions framework, that cognitive solutions agenda, to be a little bit more specific. Specifically, the topic of the ecosystem. So the ecosystem means everything also outside of the company. How do we get these things set up? I will start with a short introduction of Evonik, not because I want to do marketing, because honestly nobody's going to go out after this meeting and buy a kg of silicon dioxide or polymer, but it's really just for you to understand what we do and how we do it, because that kind of influences how we implement these technologies, right? We just heard it from you, Oksana. You also said every company has to deal with that whole change in a different way. And we're not a soccer company, by the way, so I want to make that clear already. Then we want to talk about why AI is actually relevant for the chemical company. So why do we have to look at this? And why is it a challenging topic for us to work on? There are a few reasons there too. And then finally we get to this ecosystem and how we have decided and are working on implementing these topics for us. Okay, so Evonik. All of these products that you see up here, we do not make. So that's maybe an interesting start. What we do is we add functional materials, small amounts typically of functional materials to these products that really then bring the function to the forefront. So for example, that make tires more fuel efficient, towels more fluffier, mattresses bouncier, and so forth. So really adding the functions to those end products, if you want to call it chicken and end product. To do that, we always say we don't just do chemistry. You know that life happens at the interfaces, innovation happens at the interfaces, function happens at the interfaces. So we also look at biology, we look at mechanics, at physics, whatever is necessary. And we do this with our own people, of course, but we're not huge, we're not small, about 33,000 people. So we also, of course, work with a lot of external parties. Just a few numbers, about 15 billion sales, healthy EBITDA margin, again, 33,000 people. But even there, we have more than 10,000 products, depending on how you count them. So really, again, very, very specialized. And this kind of shows you that we are a company that is very much into, I would say, developing, trying new things, specifically technologically, right? So it's really interesting to us to kind of do this. And the German word Tüftler is often being used for that. So tinkering and trying stuff out. And that's good on the one hand. On the other hand, it also leads to us trying to do a lot of things ourselves versus just building on what's out there. But we'll come back to that later. Okay, so that's kind of our motto, our mission, leading beyond chemistry to improve life today and tomorrow. And of course, when we look at how to do that, we look at all kinds of enabling technologies. Again, today I'm going to focus on AI, but it's just one example. It can be any other technological and methodological upcoming thing. So AI specifically, and you all know that, it was mentioned this morning, it really is mushrooming, right, in terms of where it's coming up. And there's many, many numbers to kind of underpin that. I suppose all of you know Moore's Law. I've heard about that, right, in computing. It was set up a few decades ago. And Moore, that's where the name comes from, he basically said every 18 to 24 months, the capabilities or the computing power doubles. And it has been true for all those decades, right? Even today. The interesting thing is if you look at AI solutions, since the last AI winter passed and the new kind of AI summer came, which was about 2012, 2013, with the advent of neural networks, because AI is not new, it's been there for 70 years, but kind of the next big wave came around that time. They say it has been 3.5 months. So this is really exponentially super fast. It's really hard to keep up, right? It's important to understand that. This is unbelievably fast. You can also see it in some other quotes. So you have here investments in AI are set to reach 232 billion. It's hard for me to fathom. It's just a lot, right? So in the US alone, by Q1 2022, this year, there were already more than 12,000 known AI startups just in the US, right? And again, this doesn't include all the hyperscalers, all the consultants, all that kind of stuff. The number of AI patents has increased 30-fold since 2015. And of course, everybody's trying to find these people that can actually implement it, which is really interesting because if you went 10 years back, 15 years back, being a mathematician, you know, it didn't really guarantee you a job. Now these days, you know, no problem. You can just choose from a whole roster. Okay, so it is really moving very fast, and I think it's clear it has arrived. But the question, of course, is what is it? And I don't want to go too much detail. I'm an engineer, not going to talk about the details too much here, though. But just as kind of an introduction, artificial intelligence is really more of a framework. It takes typically data, it is in computer science, and it then tries to basically do pattern recognition, for example, and create use from that data. We use cognitive solutions in our company for a number of reasons. One being that artificial intelligence is a topic that can be contentious, right? People can be afraid of it. It's also very fluffy. I'll talk about that in a second. So cognitive solutions is an even higher framework, so to speak. It kind of it talks about making use of data, specifically to enable intelligent processes, products, or business models. And I'll come back to that later too. So I think it's clear it is relevant. The question, of course, is it just our impression or what do others say? And we did look a little bit outside and I brought a few quotes that I found quite interesting. This, I think, is clear. It is out there. Everybody knows that. There's no question about that. We also know it's going to be embedded in all aspects of human activity. I mean, everybody individually at home already works with AI to a certain extent. There's also a business perspective behind this. So certainly you would expect that there will be, for example, a high return on equity if you deploy this. And there's some companies like, I think this was Accenture, that even tried to put some numbers to it a few years ago. So you have here, again, we're a chemical company, a 10 billion chemical company could increase its top line by more than 2.7 billion and reduce its operating expenses by almost 8 billion. So this is a significant improvement in the bottom line in the end. I'm not here to contend those numbers if they're right or wrong. It doesn't really matter. It just shows that there's a lot of potential in there. But you can also see that some companies have changed their business models. Somebody yesterday talked about Lego, right? Going from the bricks, now having movies, having games, all that kind of stuff, really adding digital products. This is not what we do, though, I have to be clear, right? We are not an AI company. We're never going to be an AI company. We make materials. It doesn't mean we don't have to look at AI. We have to add it as an enabling technology, but we're not going to compete with Google, right? I have to be very, very clear on that. We're not going to be even competing for the same talent as Google is. We need a different kind of resource. Some companies, though, say, and I forgot who this is from, that any organization that is not a math house with an A, not an E, I always have to be clear, now or is unable to become one soon is already a legacy company, right? I don't know, right? I have to be clear on that. I think we have to look at this. I don't see it as critical, but certainly it is a technology and a methodology we have to use. Now, to put it a little bit more into perspective again, this is not a magic wand. It can do a lot. You have to look at it, right? Don't ignore it, but it's not just going to solve everything magically just by itself. I mentioned before we don't use AI as the main topic or the main name here. One reason for that is that it is a shifting target. So John McCarthy said this, I think like 50 years ago or something like that, or 60 years ago, and it's still true today. So imagine you being at home in 2000, year 2000, and having your phone talk to you. This would have been magic. This would have been definitely AI, right? No question asked. Today, this is just, you know, voice recognition, speech technology. It's just an algorithm. So the perception changes, right? Everything that is possible today, you don't see as AI. Everything that might be possible only tomorrow is still AI. So it's a moving goalpost. I said that before, I'm going to repeat it again because it's really important for us how we set up our strategy in that area. Again, we're not an AI company. We have to add this to what we do, but it's not going to be our core. We are good at making, developing, selling chemicals, and that's what is going to stay. We just have to add these technologies from blockchain to AI, quantum computing, and bring it in where it makes sense. Okay, so I mentioned before the lower part here, we try to kind of see where can we make use of AI. And there's two different ways of how we look at this. The first one is discovery versus accuracy. You can use it to discover things that you didn't know before. That's one way. The other way is to make it part of your processes, for example, in a way that it does things that you've done before, but do it more automated, do it more holistically, do it better if possible, with less variation and so forth. The other way, and that's what I typically tend to use, is process versus offering versus business model. So what does it mean? You can try to do things that you do today, like in R&D, in marketing and sales and production technology, in your business processes with AI, with cognitive solutions, and do it in a better way. You can also try to make it part of your product. So think about the Echo Dot, right, from Amazon. You buy the speaker, of course, the hardware, but you also buy it because it has this speech interface, right? So there's an AI component that you actually pay for. For a chemical company, this is much more difficult, obviously, right? You cannot put a speech recognition on liquid, for example. But there are some ways that we can do this and that we do this. Most important, maybe long-term, is the enabler for new business models. This is very complicated, honestly, but very interesting. So think, for example, about the agrochemical area. So farmers, right? Farmers in the past, they would buy a tractor. They would maybe buy some weather data. They would maybe buy seeds and pesticides and then try to kind of solve that problem. Now, today, the first kind of, I would say, offerings are out there where there is a kind of an orchestrator. And this orchestrator gives you the know-how plus the data, so a tractor, the pesticides, the seeds, the weather data, the soil data, and it gives you the AI, real-time AI, that tells you, please do this then and there. Here you need less, here you need more. And in the end, it's being paid not just by the seeds or the pesticides, it's being paid by the amount of wheat, for example, that you produce. So you really immediately go for the KPI of the customer, right? Instead of just selling stuff by the kg. And this, of course, has multiple benefits. Number one, it really goes for sustainability. You try to cut down on use because there's no benefit of that anymore. You don't sell by the amount. And you really go for the KPI of your customer. So this is going to be really important, and we're really going to see more and more of that coming up also in our area. But of course, with 10,000 products, it's difficult to see what role we can play where. But this is only really possible through AI because it's real time and it can really manage that complexity. Okay, so these are the three areas we're looking at. Most of the work is certainly in the work process. I'm going to jump over this in terms of time. The question is, if you then are aware you want to use AI, it's not as easy as it sounds to actually do it. AI is growing very fast. As I said, AI is not just one algorithm. This is just a machine learning overview, and it doesn't go all the way down. So you have cognitive solutions, you have AI, and then you have within that machine learning. Machine learning is kind of the technology that has been driving a lot of the hype in the last 10 years, starting with neural networks. So you learn from data, you build your models from data instead of having to program them. That's the main idea there. You don't have to read this. This is not why I put it up here. I just put it up here for you to see that it really branches out. And this is not the end of it. It goes further down. So there are hundreds of different approaches. And very often, if you want to have a solution, you have to build together multiple building blocks, like your brain, right? You have a visual recognition, you have a memory, and so forth. You have to put all that together to really get to a solution. And in order to make sense of that, you're going to need people who are able to handle that complexity and who know how this works. And here we have, of course, then, there we go. We have the data scientist, which I think was the economist said is the most sexy job of the 21st century, which is again interesting because it's kind of a mathematician, right? Who would have known? But these people are really the ones that understand these algorithms. They understand the problem and are able to then find the right approach. But you need more people. This is honestly only 10 to 15% of an application. So you're also going to use a data engineer who has the data pipeline. You're going to use a machine learning engineer who actually makes it into a working product. So you can see a machine learning engineer as an analogy, like a normal engineer to a physicist. The physicist, does all the theoretical stuff, but then you have the engineer who builds a pump, for example. Software developer to bring it all together, and the data analyst who understands the problem, who helps the data scientist with the domain know-how, and then maybe also later on actually uses the solution. Now, what most companies do, including ours, starting maybe around 2010, 2012, maybe a little bit earlier, is they started building their own applications, right? And that's not bad because that's how you learn, right? By just tackling problems, coming from your problems, and then adding technology to it. So they go from conception to prototyping, full stack MVP, minimal viable product, product development, and product support. Many cases honestly stay in the MVP phase, which is fine. If they're very focused, you don't need a huge service level. It doesn't have to be scaled. That's okay. Some, not many yet, are all the way into product development and product support. So you can do this, but there are really a few major downsides to doing this by yourself. So number one is that, as I said before, there's really a breakneck speed in developing new algorithms, new approaches. Right? And for building these in-house, it means you have to keep up to date. By the way, I'm saying building, that's maybe important. I'm saying building because in a company like ours, we are not developing new algorithms. Have to be very clear on that. What we do, and like most data scientists out there, they go to the libraries, like the PyTorches and so forth, and they pull the building blocks that are out there and build them together in a good way. That's why I say build. We do not do algorithmic research. That's beyond what we can do. But it does mean that all the time new stuff comes out. So if I build something and I know already 3.5 months, maybe there's some new approach out that is doubly as fast, should I revisit this? Yeah, or can I just let it rest? So that's really an issue. The second thing is, if it's then out there, how is the application actually performing? Right? Is it drifting in its performance? I have to monitor that. It also means I might have to do retraining because again, you have to remember, this is not a model that I built. This is a model that has been learned from data. Right? So if my data changes, if my surroundings change, my model will change and it might not be performing. I have to be retraining it. So it's an additional layer of complexity to regular software. And then the next thing is that we tend to make very, very customized, very narrow solutions. Right? If you want to get that last percent, that last 0.1% out of your application, you become very customized and you very quickly get a big zoo of different applications. So for our company, we're way over 100 self-built applications today. And I'm sure that we cannot go on the same way as we did maybe the last 5 years because we're going to have 1,000, 2,000, 3,000 applications. We cannot maintain all of them. So the main question we have asked ourselves is, how likely is it that a non-AI company can develop competitive AI applications across the board? So for everything, no matter if it's reading an invoice, right, to doing a smart DOE for materials discovery and so forth. The answer, of course, is it is very unlikely. I mean, there's billions and hundreds of billions of dollars going into all these companies outside that have really talent that is developing very narrow solutions. So why not make use of those, right? Why try to develop everything in-house? And it's interesting because to many companies that we spoke to, specifically until like 2 years ago, they didn't even think about that. It was all about, no, we have to do it ourselves. You know, this is going to be our competitive edge. Keeping that competitive edge is going to be more and more and more complicated. We're also not a software company, right? Just because we can build Excel or Aspen or a customer relation management system, we're not doing it, right? It's not our core capability. We are a chemical company. But this is something that really comes with time, right? With new technology, you start by doing it, by learning it, and then at some point you might switch. So what about taking those same people, but actually letting them look outside of the company? So looking at what's out there, judging it, evaluating it, then bring it back into the company and still work with it, right? Like if I take the example again of Aspen, I don't know who's aware of Aspen. It's a modeling, or let's take CFD, maybe it's easier. So computer flow dynamics, where you simulate flows, right? Instead of developing that solution yourself and then working with it, why not buying it from the market, which has a nice front end, it has all the security management, all the patch management and so forth, and then have your own data scientist, for example, working with it, right? So you buy something that's already targeted to your problem that you then just use inside. So these people don't go away, don't get me wrong. They still have a very important role to play. You just use them a little bit differently. And of course, they still will build a few own applications. So this is how I see the company today, and I think where we should go. So I have to be careful there. And actually, it's not today, it's 2020. That's on purpose, because then if my colleagues, and actually there's one colleague here, if my colleagues should see this at some point, they're not going to be contesting, oh, it's actually not, 85%, it's 83% or whatever. So it's not really important. It just gives you a kind of a, qualitative picture of where we are. So far, what you see here is that most of the things we try to build ourselves. right? So we build these solutions by ourselves because we think it makes sense. It might have made sense. We have a few commercial narrow solutions. So we are an SAP company, right? So SAP has a module that's called Concur that is able to read your travel expenses or stuff like that. So it kind of came in more as like a surprise, or it wasn't really planned. It just came with the software that we have already, right? And that's of course how these things also come in. Then we have external developments where we say we don't have the resources or we don't have the know-how. So we try to work with external parties to develop something, but it's similar to the internal build, just again with external parties, typically not research. But then we also have custom research. Now, why would we do that? Because we say, although in most cases we don't have to be all the way up there, right? How we read invoices, if we're half a year later, it doesn't really matter that much. It's a little bit of efficiency, but it's not going to kill us. But in a few areas, it might really make sense to invest in research. So again, we're a specialty chemical company. If we are able to bring to the market products 3 months, 6 months quicker than other companies, well, this is maybe worthwhile investing in, right? So for those things, we do work on research, but we don't do it in-house. We don't have the right people for that, and we don't have the resources for that. So we do it with external partners, but talk about that in a second. Now, where do I think we have to go? And again, it's more a qualitative view is, let's say 2030, right? Most of the solutions we have, like in software today, should be bought. We should not try to build those ourselves. It just doesn't make any sense. There might still be a few where we don't find something on the market and where we feel they have to be more specialized, then we can still build them ourselves. We still have a little bit more of external development probably because we don't have enough resources in-house, and we have a little bit more of the custom research one. But you see the big change, right? And again, this is, I want to be clear, I'm not doing this to diss on my colleagues, right? This is just how a company gets used to a technology. It's just a normal maturity curve, right? And we're not different than many other companies here. This is for AI. AI, yes. So if you want to do that, you have to prepare for that, right? And what we tried to do is indeed have the ecosystem in place, and that's the title of the whole presentation, so finally getting there, to make that happen. There are two halves on this slide. You see on the right-hand side the actual implementation. On the left-hand side, some additional things that I might be getting to in just a few seconds. I'll start on the right-hand side. So we talked about the internal resources. You need those to internally build, but also to judge what is out there and bring it into the company, translate it for the company. But to give you a number, in Evonik we have about 50 of those people, right? It's not nothing, but it's also not a huge amount. But we're also not going to have 200 in 2 years. That's not going to happen. Then you need the commercial suppliers, right? So, and we have just alone looked at over 250 of them. They have been cataloged and they're visible for all the people in the company, but there's just a lot of stuff out there, right? Then you need startups. There are some cases where you need more flexibility, where you need to be able to maybe have moving goalposts and so forth. So here we are working, for example, with not our internal formats, but external formats where specific parties bring together startups and challenges from corporates. We also have venture capital, which of course gives us another alleyway into that ecosystem. And then we have the academic partners that I mentioned before. So for us, this is MIT, or specifically the MIT IBM Watson AI Lab in the US, where we're able to really work within any of these topics, be it quantum computing or quantum machine learning, anything. And we also have, and that's very nice, in terms of retainment, you also have the possibility to bring in people into, for example, Cambridge and work there, which of course is very interesting for a data scientist. So this really helps us to implement, right? And I think it's fairly complete. On the left-hand side is an additional building block, which is more about learning, exchanging, and drive. So we have strategic partnerships, for example, with IBM, where we really look long-term. What happens to the technology? How is it going to be deployed? What is going to come up? Also for more complex projects, you might have a long-term partner there. Consortia, so working within, for example, in Germany, BMBF or these kind of constructs, allows you to work within the ecosystem, suppliers, customers, try to work on standardization, right? Working together in a project. And then peer exchanges, which means you're looking within your industry. So in German, Marktbegleiter, right? So like for us, that would be, I don't know, for certain areas, Merck or Bayer or Covestro or Lanxess, Clariant, and so forth. So with them, of course, we don't discuss prices and products, but with them we discuss, okay, how do you handle this change, right? You're in a similar situation as we are. So how do you organize yourself? centrally, decentrally? What processes do you put in place? And so forth. So we can just learn from each other because, again, it might save us some time. For example, Clariant might be further in one point, we might be further in another point, and we can just, avoid these stumbling blocks along the way. Now, I'm looking at the time. To build this, you need quite a bit of effort. I'm not going to go into this right now because I want to save my time for the last slide. But you need to start building that now so you can make use of it 1, 2, 3 years down the road. This is a lot of effort. I want to be clear, right? So you really have something in place that is functioning. Now, once you do have it in place, I do want to highlight one last thing, is then how do you actually make use of it? And we had a situation that because this is a general purpose technology, that people just jumped on this topic. If somebody came up with a topic and application, whoever heard it first just started working on it, right? Even if it was maybe double work, because at 33,000 people, we still don't know what everybody else is doing. So what we did is we put something in place that we call front-end loading. Again, I'm an engineer, so front-end loading comes from engineering. It means putting a lot of work in the definition of your problem. So you save money later on when you implement because you don't have to change everything again, right? So it's basically a pretty simple idea. And what we do here is we have, for example, a digital activity scout. That means if somebody comes up and says he wants to do predictive maintenance, then you go in there, you type in predictive maintenance, and you see if anybody else in the company has done that already. And there's a name, and you can call that name, say, hey, what is your business case? Was it worthwhile? Is it working, right? Can I just jump on? So you don't do double efforts. I mean, it's a super simple idea, but it really helps. The second thing is, if there is no previous case, then you have the AI canvas. Again, super simple, takes you 1 hour. You can get help to fill it out, or you do it yourself. It has a few basic questions. What kind of prediction do you need? What are you going to do with the prediction? What will be the effect if you use that prediction? When will you trust the prediction? And so forth, right? Very simple, because then what happens? Typically, it already changes here in terms of what they really want to achieve. It then goes into alignment. Here we have about 6, 7 people from different teams within the company worldwide that look at this and say, okay, cool. Yeah, we don't have that. It makes sense. It can be done. Sometimes it just cannot be done. Might be very expensive and so forth. Then you get one person that goes back to the use case owner. And then with the use case owner, there's a make or buy process. It's about 20 criteria you go through, and it's not like black or white, right? But it just makes sure the use case owner understands the implications of making a choice in terms of maintenance, in terms of know-how, IP, and so forth. So they can make an informed decision. It's another 1.5 hours, right? So this whole process, because it's, you don't get everybody at the same table all the time, it might take a week or 2, right? But then you are really ready to make an informed decision without doing double work. Because then you go into the POC, proof of concept, the MVP, or the pilot meaning you take the external software and try it on your problem. Again, many cases will stay here, and that's fine because they're very limited and very focused. In some cases, you might also have to go to operationalization, so bring it into a service level, scale it, and so forth. This is something we're really struggling with yet, as, again, most companies. Again, we all go through the same kind of learning curve, but this is also part of our, I would say, maturization in this area. Right. Okay, I hope I could give you at least a little bit more actionable points. I tried to go a little bit deeper than just kind of stay on the high level. Again, it's just one building block of this cognitive solutions agenda. But I think at least for the typical legacy companies, it might be worthwhile to really think about the long term. What can you actually maintain, and how should you be set up to make use of the ecosystem overall? With that, I'm done. Thank you.
Thank you very much, Yves, for this